Welcome back to Let's Make a Game, a channel about making computer role-playing games using the free program Twine and the Sugarcube format for Twine. In this video, I would like to keep talking about my current project of coding the combat system for a viewer's game. In my last video, I showed you how I had coded the monsters deciding what to do, and the system was very simple. Each monster had a single attack, which only had a range of close, which is like 1 square away, and they would simply see if there's any player character or companion within range, and if so, they'd attack one of them, and if not, they would move towards a player character or a companion. And I did mention briefly that I had to speak to the creator of the game, because I didn't have all of the numbers that I needed, and I have spoken to them since then, and it turns out that they wanted something slightly more detailed. There are multiple sort of types of attacks, and a particular type of enemy might have 2 or 3 different attacks that they can try, and also they didn't want them to just sort of rush into combat. They wanted them to sometimes be a bit wary. So I've coded both of those things, and that's what I'm going to show you, and then I'll discuss the code. So we have a combat I've set up here. We don't have any companions, and enemy 6 has won the initiative. Oh no, sorry, enemy 14 and enemy 6 have won the initiative. So they should act first, so let's press continue. Okay, so we have here, we're printing out all of the enemies. They're at distance 5, and then the player characters at distance 0. So that's all, down to this horizontal bar, that's all stuff that we've seen in the previous video. But we can see here that it seems to have become slightly more complicated. So we say enemy 6 chooses the attack buzz. Well, that suggests that there's more than one attack that they can choose from. And of course, if you kept running this program, you would sometimes see different names of indicating different types of attacks. Since there is no target in range, enemy moves. Well, that's as before. And now we have this. We have enemy 6 rolls 9, and so wants to move towards player character. Sorry, toward player character. And then these 3 lines are basically the same. They chose buzz again, no target in range. They rolled a 7 this time, and they want to move towards player character. So you might wonder what these numbers mean. And again, if you ran the program several times, you would eventually find that high numbers tend to mean that the enemy wants to move away from the player character, and low numbers mean that they want to move toward the player character. And the specific way that it works is that the random number, the number that they roll, is just the equivalent of rolling 2 6-sided dice. So it's a random number from 1 to 6 plus another random number from 1 to 6. And that is compared to their hit points. And if the rolled number is greater than their hit points, then that makes them wary and they move away from the characters. And if the number is lower than or equal to their hit points, that makes them want to get stuck in and they move towards the player characters. So over time, in a combat, as enemies get wounded, the ones that are wounded will tend to get a bit more cautious. So the ones that have low hit points will tend to sort of hang back, and the ones that still have high hit points will tend to go forward. So it will hopefully make them act in a slightly more realistic way, and hopefully a more interesting way. So let's have a look, and so it continues. So actually we can see here enemy 14 rolled a 10, and so they want to move away from the player character, but then in their next action, because remember everyone has 2 actions in a combat round, they then want to move towards. So they're sort of the equivalent of they're not quite sure, I guess. In real life, that would be what's happening. They sort of, they move back, no, I'll have a go, sort of thing. Which is, of course, a waste, moving back and forth. That's not something you would choose to do in a game. It's not like an optimal move, but it is something that happens in real life because, of course, especially in sort of fighting and high stakes situations like that, people are often quite conflicted about what to do. So hopefully that makes the it makes the players, it makes the enemies a bit more realistic. It also should have the effect, because they're not choosing an optimal move all the time. It should make the combats a bit easier for the player character and their companions, which is another thing that the person who is making this game wanted. They're a little bit worried that the combats might be too deadly, because there's going to be sort of several in a single game. So that's what I've done. Let's now have a look at how I did it. Let's look at the code. So most of the stuff that we're going to look at is down here. I've expanded. These two passages used to be a single passage dealing with the enemy moving, because the enemy movement is now more complicated. They might move away or they might move towards. It was easier to split it into two passages instead of one. We've got quite a few changes to variables or new variables. So let's start by looking in the initialize passage. So this is an entirely new array. What I had before is we had enemy underscore ATT gave the details for each type of monster, and one of the details it gave was the numbers for their attack. But that's now done in a slightly more complicated way. So we have, for each type of monster, we have its name, we have its stats, the strong, sneaky, smart, sexy, etc. This bit is new. So slot 5 is the number of attacks that this enemy has access to, and then the slots after that are the numbers of those attacks. So the male has 2 attacks, and we can see that they are at 1 and 2. The female has 3 attacks, which are 1, 2, and 3, and the pupa has 1 attack, which is attack type 4. And all those numbers refer to the attacks array, which is up here. So we have, as is written down here, slot 0 is the name of the attack. Slot 1 is what attribute is used in the attack roll. So that's strong or sneaky, basically. The way it works is that sort of close range, hand-to-hand type attacks use strong, and ranged attacks use sneaky, even if they're used at close range. Slot 2 is the range, where 1 is close, 2 is mid, and 3 is far. But we have to remember that in terms of squares, or in terms of range bands, 1 doesn't mean... Well, actually, 1 does mean a range of 1, but 2 doesn't mean a range of 2, and 3 doesn't mean a range of 3. It's 1, 3, and 5. So there's a note here that we don't just take this number. We have to take the number, multiply it by 2, and then subtract 1, and that will give us the correct number. So, for example, 2 by 2 is 4, minus 1 is 3. 3 by 2 minus 1 is 5. Then we have the basic damage. We won't be dealing with damage because I'll be dealing with attack rolls and the consequences of those in a video to come. But that is the basic damage. And then there's a special type of attack which doesn't do any damage, but the enemy, or the enemy, who would be the player character or a companion, has to roll, and if they fail, then they are knocked prone. And that is indicated with a -1. And then we have the attribute that is added to the damage, which is always, in this case, it's always strong or none, which is indicated with a 0, which is that buzz attack, because that doesn't sort of do, it doesn't do damage. It's sort of buffered. It's the idea in the fiction of the game is that they're sort of waving their giant wings so fast that it creates a wind that can knock over a particular target. We also have a variable that is essentially new. I've changed what it is, what it does. So let's get down to that. It is NME underscore TYP. That used to be the number of different types of enemies, i.e. the number of enemies that were in this array. But we don't need to have a separate variable for that, because we can use .length. We use NME underscore ATT dot length, LENGTH, -1, and that will give us the number of entries that are in here, assuming we've started from 1 and numbered up by 1 each time, which of course we should do. And not having a separate attribute for the number has the advantage that we can add more or take stuff away, and we don't then need to update a different attribute, because .length -1 will be different automatically. So that's effectively a new attribute. It used to be how many types were in this array. Now it is the type of the currently acting enemy, because we get a lot of information that we're going to use in combat from their type, because all the monsters of a given type have the same strong attribute, the same sneaky attribute, the same attacks that they can do, and so on. All right, so let's look at this little subset, which is the enemy having a go. We have to find the closest character, find how far away they are, and we store that in $X. And we've done that. I've talked about this code, but essentially you need to know what's in this comment. The closest enemy is $X range bands away. Then there's a little message that all messages on this page are testing only, because, as you might remember, the idea is for the combat display to be a picture, right? It's not text, and most of the messages won't appear. Some of them might stay, but basically they're all, most of them will go. So I've left a little message saying that they're currently considered to be testing only. So the first thing we do is we find the enemy type, because we're going to use that in a few places, so it's convenient to have it in its own variable. Set enemy underscore TYP equals enemy, and the first number is $INI underscore WHO, and the second one is 1. So INI underscore WHO is who is currently acting, and if it's, for example, if we're on this, in this section, it's the enemy acting, and so, for example, 4 will represent enemy 4, 3 will represent enemy 3, and so on. And this is where we store the type. We store it in enemy something 1. So we get the enemy's type. Then we choose a random attack from those that this enemy can do, and we store in Y. So we do that in 2 steps. We could do it in 1 step by putting this code, by putting this code in here, but it would make it's a lot easier to follow if there's 2 lines. So we set Z equals a random number from 1 to enemy underscore ATT enemy type 5. And you might remember that that's where we store the number of attacks. So it looks up the type, it finds the type of the enemy. So it might say, right, it's enemy 2, which is I think a female. And then it'll look in enemy attacks and say, all right, enemy underscore ATT 25 has 3 in it, indicating that this type of enemy can do 3 different types of attacks. And so I will create a random number from 1 to 3. And then we look in enemy underscore ATT enemy underscore TYP something again. You notice that that's the same array, and this number, this variable is the same. But instead, instead of looking in 5, we're looking in Z plus 5. Because remember, slot 5 has the number of attacks, and then slots 6, 7, 8, 9, however many we need, have the number, have which attacks those are. So if we rolled a 1 in this one, or rolled, as it were, rolled, a 1 in this one, then it'll look in slot 6. If it's a 2, it looks in slot 7, and so on. And it'll get some sort of answer. So let's look at an example. Let's say that it determines that the enemy type is 2, which is the female. It'll look in slot 5, so 0, 1, 2, 3, 4, 5. It'll see that there's 3 attacks in there. It'll generate a random number from 1 to 3. Let's say it generates a 2. Well, it looks in slot 2 plus 5, and it sees that it's number 2. And it'll go, right, they want to use attack type number 2. And if we look in the attacks array, we'll see that that is the swipe attack. All right, so then we find the range of the attacks. And I said before, we have to do a bit of converting to get from the range that's in the attacks array to the actual range in squares. So we look in attacks, Y, because that's the number of the attack we're using, 2, because that's the range of a given attack. Then we multiply by 2, and we subtract 1. And then we print a message. Enemy INI underscore who chooses the attack, attacks Y0. So it's a bit difficult to see here, but I have a single quote before the double quotes. A single quote is just treated as a character. And I have another one over here. So it'll say enemy 3, for example, or enemy 7 chooses the attack Buzz, but then Buzz will be in single quotes. So having chosen that attack, we go, well, is anyone within range of the attack? And we have stored, you'll remember, we have stored the closest enemy in the temporary variable $X. As per this note, the closest enemy is X range bands away. There aren't any attacks that have minimum ranges. Like if an attack has a range of 5 squares, you can still do it at 0 squares away. So we only need to look at whether the closest enemy is within range. We don't need to check whether they're too close, because there are no attacks that are like that have a minimum range. So as per the note, if anyone's within range of the attack, we'll make that attack, and if not, we'll move. And we just ask, is W, the range of the attack we've chosen, greater than or equal to X, the distance of the closest enemy? In other words, is the range of this attack at least equal to how far away the closest enemy is? If so, well, great. We can choose a target, and If not, well, that's no good. They're all out of range. And as per the message here, since there is no target in range, the enemy moves. So we're going to end up going to either choose target or enemy moves, which I will tell you about now. Let's look at enemy moves first, which is that one's a little bit simpler. This code, you'll see that is very similar to what's in choose target. It's just that there's an extra step in choose target. So we choose target to move towards or away from. We set Z equals a random number from 0 to com_max. Com_max is the maximum number of companions you can have. So 0 means the player character, 1 means companion 1, 2 means companion 2. And if we increased com_max, and so on, 3 would mean companion 3, etc. If Z is greater than 0 and com Z2 is less than 1, well, com something 2 is the hit points. So if Z is greater than 0, in other words, we've chosen a companion, and that companion's hit points are less than 1, well, that means that companion is not there. Either there never was a companion in that slot, or they are dead. And either way, that's not a valid choice. So we have to choose again, as the note says, and we do that by include enemy moves, which this is enemy moves, so we just go up to the top, and so we keep doing it until we choose one that's we either roll a 0, which is the player character, because the player character is always going to be there, or we choose a companion, and that companion has at least 1 hit point. And when we do that, we will go to enemy moves, sort of Roman numeral 2, I suppose that's called. Okay. So enemy moves 2. Again, a little note to myself that these messages are all testing only, so get rid of them when we have the proper display. We roll, essentially simulate rolling 2 6-sided dice. We give the message, enemy 7 rolls an 8, or whatever it might be. We compare that roll to this enemy's hit points, which is stored in enemy INI_who 2. And if the number we rolled is greater than their hit points, then that means their hit points are low and they retreat. And we remember that by setting X equal to 1. And otherwise, the enemy's hit points are fairly high, and so they want to advance, and we set X to -1. So we're going to get a value of 1 or -1, which is telling us whether they want to move towards or away from their target. And also we have this message. So we set something like enemy 7 rolls an 8 and so wants to move away from, and so wants to move toward, and then we say who they are moving away from or towards. If Z is 0, it's the player character, and if Z is anything else, it's companion number Z. And we set where that target is into Y. Y is either 0 if it's the player character, because the player character is always considered to be at 0, or it's com Z3, because that's where that companion's location is kept. So now we have to work out what's going to happen. And first we say is enemy INI_who 3, which is that enemy's location, equal to Y, which is where the target is. Because that's a special case. They're in the same square or in the same range band, and so that has to be treated a bit differently. If X equals 1, which means they want to move away, then that location will either add 1 or subtract 1, because if you're in the same square as someone, you want to move away from them, well, you can move forward or back. That's both of those are moving away from them. And so we generate either the value 1 or -1, and we do that by generating a random number from 0 to 1, multiplying it by 2 and subtracting 1. So 0 times 2 is 0, -1, that becomes -1. And then 1 times 2 is 2, -1 is 1. So you'll always either get -1 or 1. Now I could have said random -1, 1, But I didn't do that because that would include the value 0, and so sometimes the enemy wouldn't move. So that doesn't really fit the text which says that they want to move. So if x equals 1, they will move in a random direction. And if x is not 1, which means it's -1, which means they want to move towards them, then we get this message, enemy can't move any closer, and so stays still. So that's a situation where they want to move closer, but they're 0 away, and so there's no getting closer than 0 away, so they just stay still. I don't know if that will ever happen, because I think that if they're 0 away, then that they will pick an attack that is within range. So I'm pretty sure that this case, I'm pretty sure that this whole case might not ever happen, but it is in there just in case, just to make the system a bit more robust. We might, for example, decide, well, I want a 1 in 6 chance that they'll move randomly, for example. And so if that's the case, then we might be within 0 range. And so we need to have some code that deals with that. But at the moment, where they're picking an attack and then checking if anyone's within range, well, if the range is 0, I think they're always going to get an attack that is within range, right? Because the minimum range is 0. So that's really just there for sort of future robustness. However, so if that's not the case, this is a bit simpler. Else if enemy I who 3, the location, is greater than y, then we add x to their location, and if none of those are the case, I've just realised I've put a wrong character there. That should be like that. Sorry about that. We set enemy I who 3, we subtract x. So here's an example. Let's say x is -1. That means they want to move towards the enemy. Let's say enemy I who 3 is greater than y. So what's an example of that? Enemy I who 3 is 4, and and y is 2. They want to move towards 2. So we will add x, and x is -1. So their location was 4 and becomes 3. And that is indeed moving towards. If they wanted to move away from them, and they were at 4 and the target was at 2, well, they'd move, then we would add 1, because that's the value of x when they want to move away from someone. And so we would add 1, and so their location, which was 4, would become 5. And of course, that is moving away from position 2. And then if enemy I who 3 is less than y, which is the only way we can get to this situation, it's exactly the same except it's reversed. So, for example, let's say the enemy is at location 2, the target is at location 4, and they want to move towards the target. So x is -1. Well, then we'd subtract -1, which means add 1. So their location of 2 would become 3, which is indeed moving towards 4, if that makes sense. So this will, and then we move on to next action. So next action, we've already talked about that. It's just either if it's the monster's first action, they get another go, or if it's not, then we move on to the next person in initiative order, or if everyone's had a go, we roll initiative again, because we roll initiative anew each round. So that is movement. Now let's look at choosing an enemy. So I've just got a little reminder to myself here. Enemy _type is the type of the currently acting enemy. Z is the randomly chosen target. Y is the attack this enemy will use, and W is the range of that attack. So this is, as I said before, the code is very similar to this one. where we choose a random number from 0 to com_max, and then we check whether that choice is a valid one. But there's another part to it. So set 0 is random from 0 to com_max. If z is greater than 0 and com_z2 is less than 1, then that means you've chosen a companion that isn't really in the fight, so we choose again. Otherwise, we do this. We find the distance to the target and we store in x. If z is 0, if we're targeting the player character, then x is just enemy ini_who3. It's just the enemy's location, because the player character is always at 0. So if the enemy is at 4, well, they're 4 away from the player character. Otherwise, we haven't chosen the player character. We've chosen a companion, and their location can be anywhere. So we do math.abs, in other words, the absolute value, which means that if we get a negative, we flip it round, so -5 becomes 5. And it's the difference between enemy ini_who3, which is the enemy's location, and com_z3, which is the companion's location. And then, so we have x, which is the distance, and then we look at x, the distance to the target we've chosen, and w, the range of the attack. And if x is greater than w, then that means the chosen target is out of range, and we need to choose again. And we do that again by that command, include choose target. In other words, we include the page that we're on. We go around to basically go to the top and start again. And we keep going. If that's not the case, which it eventually will not be, because if we get here, then there is an enemy within range, because we checked that on the previous page. So we're going to keep going through this page until we choose someone who is within range. And in that case, the chosen target is in range, and we should attack that target. And we go to enemy strikes. But as you can see, there's no code there. I have to rewrite the combat code to account for the fact that there are different attacks. But this video has gotten long enough. So that is how we have a sort of slightly more, hopefully more interesting, and certainly somewhat more realistic version of the decision making for the enemies, which is slightly more varied, more unpredictable, and also means that they're acting sort of suboptimally. They're not tactically choosing the best possible move. They might end up moving forward and back as if sort of uncertain whether to fight or run away. But I think that's a feature rather than a flaw, because that is a thing that happens in real life as well. So what I'm going to do next is the more complicated version of rolling to hit, and then after that we'll move on to assessing the damage or the effect of the special attack, which can knock its target prone. But for now, I hope that was useful or interesting to at least some of you, and I hope you will tune in next time.